interestingly, this thing. And what did \n represent? So, oh, OK, good. We'll move more quickly now. All right, so new line. And that's the way of telling the computer explicitly, put a line break after these words, because otherwise it's not going to appear. All right, so we can do things that are a little more interesting now, like not just say, oh, hi, world. Let's say, oh, hi, David, or some arbitrary name that I type in. We need the ability now to get user input, so we can actually do this with the following syntax. A word, recall from Wednesday, is generally called a string in programming, a word or a sentence. Any sequence of characters is a string. I'm going to call it s only because I only have one string. I know it's s. I don't need to give it something more descriptive. And then there turns out there's a function I can use called getString. It, too, takes no arguments. But just to distinguish the two, when you call a function that takes no arguments, you don't have to say void. You only say void in something like main if you're saying preemptively, don't pass me anything. So we'll tease these apart before long. But for now, getString, open paren, close string, is going to do exactly that. It's going to get a string from the keyboard, and it's going to hand it to me in a variable called s. But unfortunately, I'm about to run into a problem. Let me go down here. And I'm going to change this to %s, and then I'm going to put a comma s, because recall from Wednesday briefly, this is how I dynamically inserted the value of a variable into a string that I don't necessarily know in advance. I know I want it to say, oh, hi, comma, something. But to dynamically insert that something, you use a format code. A format code is just something that starts with %. %s means string. Put a string here. So comma s means take that value, whether it's DAVID or whatever the user may type, and put it inside of the string itself. So unfortunately, this isn't quite perfect. Let me go down to my terminal window. This is still called hello. And I'm going to go ahead and make hello. And wow, lots of issues here. So when in doubt, and honestly, if a whole lot of errors scroll, it doesn't mean you made an infinite number of errors. It might mean you made one, confused the heck out of the compiler. So never start fixing errors from the bottom up. Always scroll back up and try to fix the first one first. And there is the first one, error, unknown type name string. Well, it turns out we're kind of lying to you here. It turns out in C, there is no data type called string. There is int, there is float, there is char, and a few others we mentioned before. But string is kind of a CS50 simplification just for the first week or two. So if you actually want to use this data type, you actually need to use another library. So I'm just going to do some quick copy paste, because it turns out in the appliance is a file called cs50.h. And in that so-called header file is not printf this time, but functions like getString and getInt and some other user-friendly functions that just make it easier in these first weeks to do simple, reasonable things. So now I'm going to save this file. I'm going to go back to my terminal window, and I'm going to go ahead and rerun make hello, enter. And now all is better. I still see this cryptic command, but I don't see the word error. So now all is better. So now let me go ahead and run /hello. Nothing seems to be happening, but that's because it's waiting for some input. So let me try typing my name, enter. And indeed, it now says, oh, hi, David. Well, we can make this marginally more user-friendly. Let me scroll to the top. And rather than just kind of blindly get a string from the user, let me first say, you know what, printf, say your name, colon, space, semicolon, just to kind of format it in an interesting way. Now let me go back to the bottom here. Let me rerun hello and hit enter. And bug. Yeah, not really a bug. It was just a stupid mistake on my part, right? Because I didn't recompile the program. Oh, and as an aside, if you kind of get stuck in this awkward moment where your program's running and you didn't want it to run, almost always Control-C is your friend, and that will quit out of whatever program you're running at the command line. Control-C, and it just looks like $C when it actually appears. So let me rerun make hello. That looks good. Let me now rerun hello, enter, and now it just looks a little prettier. Still underwhelming, the end result, but at least now it's becoming a little more user-friendly. Yeah?
Like if we do not program in C within the CS50 application, so what do we include at the top instead of CS50.h?
If you do not, so to be clear, for all psets, you should start using the CS50. In general, you could download something like the CS50. You could download the CS50 library on your own computer if you were programming outside of the appliance. Or more generally, there's other functions altogether called scanf or scanf, which are generally used instead. But again, more on those in the future. For now, the CS50 library simplifies these details. Any other questions? Yeah. Oh, yeah, over here.
You said that it doesn't take an input, and we are actually giving it an input when we give it an
An excellent question, an excellent point. So I seem to have contradicted myself, whereby I said main does not take any input, and yet here we are clearly taking input from the user. So long story short for today, there's two types of input. When you run a program at this so-called terminal window, recall that we're typing things like make, hello. Well, the program in this case is called make. And I'm passing it input, the name of the program I want it to make. So this is what we'll call in a future week a command line argument. It's input you provide when the program is run. And you can't really do this in a GUI, a graphical user interface, because you either double click an icon to run something or you don't. At a command line, you can type words after the name of the program to provide it with input. But notice what I've been doing. I've just been saying hello. So in this sense, does hello not take any command line input? It does take input later, but it takes it via a different channel, a different mechanism, and that mechanism in this case is called getString. So we'll come back to command line arguments before long, but for now our programs will remain relatively simple so that we only get input inside of the program itself with functions like getString and the like. Any other questions? Yeah?
Like this is quite a minor one, but to do with the spaces in each line, like where you press the space.
OK.
Does it matter, for example, that the space often comes before get in terms of what the program?
A good question. A word on spacing. So what I have done now is what we'll call a matter of good style. The fact that I've hit the space bar after this comma before the S is not strictly necessary, but it makes ultimately the code more readable. Not necessarily if your program's only 5 lines long, but when your program's, as they will be before long, 100 lines long, or even more, it just makes it easier for the human you to read it, or even colleagues of yours with whom you're working. Similarly, here is this a convention. I am indenting, just as we did with Rob on the stage when we did PBJ. He indented the pseudocode as we typed. Similarly here, am I hitting tab, or really 4 spaces, to actually indent my code to just make it more readable and more clear what the control flow, so to speak, is. So you'll see in problem set 1 that we ask you to read a short style guide written by CS50 that essentially gives you some quick do's and don'ts as you figure out exactly what kind of style you yourself like with which to write code. Yeah?
You mentioned earlier that main function is going to return an integer or something. Sometimes you see programs that explicitly say at the bottom that return 0, so can you simply comment on
A good point. So you may see if you read ahead, if you look at other examples online, that a lot of times people, myself included, will write at the bottom of main a statement like return 0, thereby being ever so explicit what the exit code is for this program. Well, I'm actually leaving that off now just as a matter of pedagogical simplicity. It's actually not strictly required. If you leave it out, 0 is automatically returned for you. So for now, it's correct, but just a distraction, so I tend to leave it out until our programs get longer. All right, so what else is there? Let's come back in just a moment. What else is there besides just getString? Well, in the CS50 library, there's a whole bunch of useful functions. Capitalization does matter with C. So the fact that we've capitalized getChar, getDouble, getFloat, getInt, getLong, and getString is deliberate so that because they're all capitalized in this way, it just makes it more clear to you in these first weeks that this is a CS50 function and not something built into C. Because eventually we'll take these training wheels off when you can get user input in other ways, including from the web. But for now, these are all CS50 functions. So what's the difference between these? So getChar gets a char. A char, what is a char? A character. It's just a single letter or a single number that was typed at the prompt. And how is that represented? Well, with 8 bits or 1 byte. And recall when we had our human volunteers the other day, they represented a byte worth of bits. And they were representing ASCII characters. So long story short, if you want to ask the user just for the letter B, and then the letter O, and then the letter W, you can ask him or her for 3 chars, one after the other. And each of those chars will be put by the computer into a different byte, 8 bits, in order to store that value. But we'll see examples of that before long. Now there's getFloat. What's a float? It's a floating point number or a real number. It's something that's got a decimal point in it. And it's 32 bits typically, though this is somewhat dependent on the machine that you're using. And sometimes just 32 bits is too small, so we instead want to double it, and so there's a double. So the getDouble function, meanwhile, gets you a double, but it uses 64 bits, which just gives you more precision. And one of the goals of showing the video on Wednesday of the various missile mistakes was to demonstrate that actually taking into account or failing to take into account how many bits, how how many zeros and ones you're using to store your values can absolutely have significant effects. And we saw this again 10 years ago in Y2K. It wasn't quite an issue of bits per se. It was a matter of digits then, but the idea was the same. If you only use 2 digits, you're going to run into a problem when the century rolls over and you now need a 3rd digit potentially to represent that, as was the case between 99 and 2000. So what else is there in the way of types? So there is char, there's double, there's float, there's int, and there's the goofily named long. And we'll revisit these before long. In the problem set, we'll introduce you in more detail to some of these. But again, a char is 1 byte, or 8 bits. A double is 64 bits, or 8 bytes, if you just divide by 8. A float is half that, 32 bits. An int is also 32 bits. And a long, just to round this out, is generally 64 bits. And so part of the problem set will actually have you playing with money, the notion of $10 million and potentially more, for which, you probably don't want to run out of bits if the downside is you don't get as much money as you're due. So you'll see in this case of pset 1 that these data types become applicable. So one other detail here. So in the CS50 library, there's not only the notion of a string, which we'll tease apart before long. That just represents a sequence of characters, multiple chars. There's also what's called a bool. And we actually had bools, or the notion thereof, in Scratch. Turns out in C, there isn't a Boolean data type, true or false. So we've created one in the library so that you yourselves can represent the idea of true or false. And we'll see some examples thereof. And then there's simple stuff, to be honest. Computers, at the end of the day, are indeed calculators. And so there are mathematical operators built into C. You can do plus and minus and divide and subtract and so forth. And just know as an aside that just like in grade school where there was a well-defined definition of the order of operations, multiplication comes before plus and so forth, most of those same grade school rules still apply. And this chart is not meant to overwhelm, but just to be a reference down the road. If you're ever wondering, does this symbol get executed by the computer before this other one? Know that charts like this exist, and you can refer back to the lecture slide when the problem arises. But the simplest rules of thumb still apply. Multiplication binds with higher priority than plus, so realize you might sometimes in code need some parentheses. Now let's finish up printf. So printf we've used %.